Hey everyone, and welcome to the whichermath channel. Hard to believe there's so many videos. I've probably done this one before, but who knows? So here we go on Valentine's Day. Happy Valentine's Day, February 14th, 2020. We've been working in class on the vocabulary of naming angle pair relationships and the characteristics of them that will then allow us to solve for an unknown number, x, and come up with missing or unknown degrees in given shapes. We're talking about parallel lines. Remember these little guys here indicate parallel. So we have parallel lines, and what's this thing called? This thing has the same name, different color. Transversal, correct. And you don't have to have parallel lines to have a transversal. A transversal just merely cuts through two or more lines, which may or may not be parallel. Okay, so let's start off. Let's just get down to business here. We've got parallel lines, a transversal, and these two angles. It's helpful if we know what this angle pair relationship is called. In this case, it's corresponding. And there's something about corresponding angles. They're same side of the transversal. See, they're both on the right side there. And one is interior and one is exterior. If we meet those requirements, what we end up with are congruent angles, meaning they equal each other, which tells us we can set up an equation using one of the angles on each side of the equality sign. And when we solve that, it'll give us the degrees of each angle. You probably already did it in your head, but since we're always practicing the procedure and the process, we're going to go through the steps. X is not measured in degrees, but X is 104. And the way we prove it is we take the one side, 110, and we test out the 104 plus 6, which is 110, and we're excited. We may or may not have solved it that way if we did not know what corresponding angles were, and that fact and those features allow us to set them equal to each other and solve what turned out to be a very simple equation. Okay, let's go to this red one now. Are these corresponding? No! We have a transversal. Let's go over the pieces and parts again. Parallel lines. And these are both inside of the parallel lines, so they're interior, and they're on the same side of the transversal. So guess what this pair is called? Same side interior. I love this term because the definition is the same as the term. They're on the same side of the transversal, and they're interior, meaning inside the lines, inside the parallel lines, same side of the transversal. Okay, which means, importantly, it means that they add up to 180 degrees. They are supplementary, my dear Watson. Supplementary means angle plus angle equals 180. Okay, so we're not going to set up this equation the same way as the first one. We're going to add them together and set it equal to 180. 4x plus 40 plus 46. I'm using parentheses just to denote that's one of the angles and this is the other one. So when we remove the parentheses, combine like terms, we end up with, once again, a very simple equation, simpler than most of the ones we've been doing in class up to this point. So the key here is really knowing and understanding not just the names and definitions of these angle pair relationships, but also the characteristics and what they actually mean can help us set up these equations. 80 minus 86 is 94. Divide by 4. Uh-oh. 23 and a half. 23 would make 92, and then 2 left over. So x equals 23 and a half. Let's test that out. 23 and a half. If that's true, then 4 times 23 and a half plus 40 plus 46 would equal 180. We're just checking our work here. 23 and a half times 2 is 47. And 2 times 47 is 94. Plus 40 is 134. Sorry, I went off screen there for a second. And then 134 plus 46. Yay, it's 180. I'm so happy because I only do one take on these videos, and if I make a mistake, I get really flustered. Here we go with our third and final problem. Hey, these two angles are just like these two, aren't they? In terms of their relationship, they are same side, interior, parallel lines. Even if I'm not saying it out loud, which normally I don't, even though that's a sign of genius, right? Even if I'm not saying it out loud, I guarantee every time I'm drawing parallel lines and putting those marks on them, I'm thinking of the word parallel. I'm thinking of the word transversal. Thinking vocabulary is one way to always study it and an easy way to master it because you're using it. So I'm going to take the 90 minus 5x from right here and the 62 minus 2x from that second angle. These are supplementary, they equal 180. Combine like terms, that means I'm going to put the x's together and the numbers together, but I'm not going to put the x's and the numbers together. That would be silly. So I have negative 7x and 152 equals 180. I take away 152 from each side, keeps the equation balanced, helps me isolate the variable. Don't be scared of the negative sign. Of course, we're going to divide by the coefficient and change that x into a positive. What's this? 52, 62, 72, 28. Hey. And then when I divide by negative 7, it gives me x equals negative 4. And if I check that out, which will be the last thing I do in this video, let's check our answer. Taking this original equation, substituting our supposed solution into it. That negative 4 is going to nicely make these negative coefficients into positive ones. Very nice. Minus 2 times negative 4 equals 180. I sure hope this one works out. 90 plus 20 plus 62 plus 8. This is 110. These are called subproblems, smaller pieces, which when put back together, make the bigger problem. Yay! So we just did 3 problems. They came out of our textbook, which doesn't matter to most of you because we all work from different books. But the good news is we all work on the same standards. So this is the standard of special angle relationships, pairs, vocabulary, and solving equations. 8G5, 8th grade standard, but it works for so many other applications. And that's all I've got to say for today. Thank you. Goodbye.